Earth is spinning faster. Should we add a negative leap second? Earth is spinning faster, and it's making scientists consider an unprecedented move, introducing a negative leap second. This year, July 9 and July 22nd were unusually short by about 1.3 and 1.4 milliseconds respectively, and August 5th is expected to be even shorter, losing roughly 1.5 milliseconds. This trend has been observed since 2020, with Earth now having slightly shorter days than in the last 50 years. A day on Earth lasts roughly 86,400 seconds, or 24 hours. But the exact time it takes for a full rotation depends on factors like the positions of the sun and moon and Earth's gravitational field. On August 5th, the moon will be at its farthest from the equator, changing the impact of its gravitational pull on Earth's rotation and speeding it up. While Earth's rotation has been slowing down over billions of years due to the moon drifting away, it has been spinning slightly faster since 2020. The difference is imperceptible to humans, but for computers, GPS, banking systems, telescopes, and electricity networks that rely on accurate synchronization, every millisecond counts. These measurements are synchronized to Coordinated Universal Time, UTC, based on over 400 atomic clocks calculating time at a billionth of a second. UTC is largely independent of day length, and when variations in Earth's rotation add up, the International Earth Rotation and Reference System Service, IERS, adds a leap second to make up for differences in astronomical time and UTC. Leap seconds can cause problems in computing systems, and an international group of scientists and government agencies voted to retire the leap second by 2035. However, with Earth spinning faster, some scientists wonder if a negative leap second is needed, which would involve removing a second from UTC if astronomical time gets ahead of atomic time. Experts have concerns about implementing a negative leap second, as the software needed has never been tested and there are ongoing problems with positive leap seconds. The probability of a negative leap second is estimated at 30% within the next decade. But this depends on factors like the potential abolition of the leap second and climate change causing Earth's rotation to slow down due to melting ice changing water distribution. Earth spins faster. July 22nd marks the second shortest day in history. Imagine waking up to find out that today is one of the shortest days in history. On July 22nd, Earth will complete its rotation slightly faster than usual, making it the second shortest day ever recorded. The difference is a mere 1.34 milliseconds less than the typical 24-hour day, which is imperceptible to us, but part of a curious trend in Earth's rotational speed that has been emerging in recent years. If this trend continues, we might need to adjust our atomic clocks by subtracting a second around 2029, a move known as a negative leap second, which has never been done before. Earth's rotation speed isn't constant. In the distant past, a day was much shorter than the 24 hours we are familiar with today. A 2023 study revealed that during a significant part of Earth's early history, a day lasted about 19 hours. This was due to the interplay between solar atmospheric tides and lunar ocean tides. Over millions of years, however, days have lengthened primarily because of tidal friction from the moon, which is gradually moving away from Earth. As the moon drifts away, it drains Earth's rotational energy, causing the planet to spin more slowly and days to grow longer. So, what explains the sudden increase in speed? Since the advent of atomic clocks in 1973, the shortest day recorded was 1.05 milliseconds, less than 24 hours, according to timeanddate.com. But since 2020, Earth has been breaking its own speed records. The shortest day ever was on July 5th, 2024, when Earth's rotation was 1.66 milliseconds faster than usual. Looking forward to 2025, scientists initially predicted that July 9th, July 22nd, and August 5th would be the shortest days of the year. However, new data indicates that July 10 has taken the lead as the shortest day so far in 2025, with Earth completing its rotation 1.36 milliseconds faster than the standard 24 hours. On July 22nd, Earth is expected to finish its spin 1.34 milliseconds early, making it a close second. If current predictions are accurate, August 5th will be about 1.25 milliseconds shorter than usual, leaving July 22nd as the second shortest day of the year. There are signs that this acceleration might be slowing down. The rate at which day length is decreasing seems to be easing, but the root cause of these recent changes in Earth's rotation remains a mystery. A 2024 study suggested that melting polar ice and rising sea levels might be affecting Earth's spin. However, instead of causing the acceleration, this redistribution of mass might be moderating it. A more plausible explanation lies deep within the Earth, the slowing of Earth's liquid core, which could be redistributing angular momentum in a way that makes the mantle and crust spin slightly faster. The cause of this acceleration is not explained, said Leonid Zotov, a leading expert on Earth's rotation at Moscow State University, to timeanddate.com. Most scientists believe it is something inside the Earth. Ocean and atmospheric models don't explain this huge acceleration. Zotov predicts that Earth's rotation may soon slow down again. If he is correct, this sudden speeding up to be just a temporary anomaly in the planet's long-term trend toward slower rotation and longer days. What do you think about this intriguing phenomenon? Could there be other factors at play that we haven't considered yet? Share your thoughts in the comments below. Join our space forums to continue the conversation about the latest space missions, night sky events, and more. If you have a news tip, correction, or comment, let us know at community@space.com. Jamie is a seasoned journalist specializing in science, technology, and travel with a passion for stargazing. He writes about exploring the night sky, solar and lunar eclipses, moon gazing, astro travel, astronomy, and space exploration. He is the editor of WhenIsTheNextEclipse.com and the author of A Stargazing Program for Beginners. Jamie is also a senior contributor at Forbes, known for his ability to translate complex technical information into plain English. Earth's spin surges. Why July 22nd might be a millisecond shorter day. Imagine waking up one morning to find that the day has suddenly gotten a fraction of a second shorter. While it may sound like the stuff of science fiction, this is exactly what a group of scientists tracking Earth's rotation are predicting will happen today. But here's the fascinating part. This phenomenon is not a one-time event, but rather a result of the complex interplay between various factors that affect our planet's rotation. The International Earth Rotation and Reference System Service, which measures the Earth's rotation and forecasts the length of the day, has predicted that today could be about a millisecond short of a standard 24-hour spin. And this is not an isolated incident. On July 9, the Earth's quick spin shortened the day by nearly 1.4 milliseconds. What's behind these tiny variations in the Earth's rotation? The answer lies in a multitude of factors, including the gravitational influence of the moon, the effect of winds and the atmosphere, and the movements of the Earth's liquid core. As Dennis McCarthy, the former director of time at the U.S. Naval Observatory, explains, "We've known about the rotation of the Earth being variable for about 100 years. This is just one of those little variations that comes along." But recent headlines about freakishly short days in July and August have sparked public interest and raised questions about the significance of these variations. So, how do scientists track the Earth's rotation? And what can we learn from these tiny variations? It all starts with good data, which goes back thousands of years, thanks to observations of solar eclipses in China. Today, researchers use radio telescopes to track the spinning of the globe by pointing them at quasars, incredibly luminous cores of distant galaxies that act as fixed points in space. This data, combined with information from GPS systems, is used to forecast the day length. But here's where it gets interesting. While the Earth's rotation has been slowing down over millions of years due to the moon's gravitational pull, there have been some surprising departures from this pattern in recent years. In fact, the last decade has seen a bumper crop of days that are somewhat short, with last year's shortest day being 1.65 milliseconds shorter than the usual 86,400 seconds. This raises the possibility of instituting negative leap seconds, or taking away a second rather than adding one, which is something that's never been done before. What does this mean for us? And why should we care about these tiny variations in the Earth's rotation? The answer lies in the importance of understanding and predicting the precise rotation of the Earth for a wide range of applications, from launching missiles to navigation to high-tech farming. As Nick Thematakos, head of the Earth Orientation Department at the U.S. Naval Observatory, notes, the Earth's moving pretty fast, so any little variations will accumulate, and it's an issue. And this is the part most people miss. Climate change is also playing a role in the Earth's rotation, with melting ice at the poles and sending water down to the equator, slowing the rotation down. In fact, some researchers believe that humans could become the dominant drivers of changes to day length, rather than the moon. As lead researcher Benedikt Sola of ETH Zurich notes, we can really become the dominant drivers of Earth's rotation due to human-induced climate change. That was really surprising and really an interesting revelation to us. So what do you think? Are these tiny variations in the Earth's rotation something we should be concerned about? Or are they just a fascinating footnote in the story of our planet's rotation? Share your thoughts in the comments below.